In this example, we're asked to compute cosine of 5 pi over 12. And if you have any vague memory of the unit circle, you should recognize that 5 pi over 12 is not something on here. We typically don't have twelfths. We use sixths and fourths and thirds, but we don't use twelfths on the unit circle. That says to me we're at one of those angles that are in between two special angles. It's not something we can just pull off the unit circle. We have to use a trig summation identity to do that. Now, when we were talking about degrees, it's kind of easier for me anyway. It's easier for me to look at an angle like, I don't know, 75 degrees and say, oh, that's just 45 degrees plus 30 degrees, right? Easy. But I can't as easily look at 5 pi over 12 and say what that is made of. It's hard for me to split that apart because maybe I'm just slow with fractions or something. So here are the two strategies you can either do. One of these. Strategy 1. Make it not radians. Convert radians to degrees. And frankly, a lot of people just stop there, like, good, we're done. Convert it to degrees and we do it the same as the other problems. That will work just fine. If you want to stay in radians, that's okay too. We just need to figure out how to turn 5 pi over 12 into something, a sum or difference of two angles. And what I think here is, well, 5 pi over 12, I know I want to use, remember 45 degrees was so useful? 45 degrees was so useful when we were doing just degrees. Well, that's pi over 4. So how can I turn 5 pi over 12 into something involving pi over 4? Well, what's pi over 4? I mean, really, that's 3 pi over 12, right? So when I say when I try to split this up, I can say, well, that's just 3 pi over 12, that's 45 degrees plus 2 pi over 12. Okay, and that's just pi over 6. So, rewriting this with with simpler denominators, I think we'll recognize some angles here. 3 pi over 12, that's my pi over 4. 2 pi over 12, that's my pi over 6. And those are both very special angles from the unit circle. Okay, if you remember, cosine of pi over 4, that's like 45 degrees. That's going to be radical 2 over 2. Cosine of pi over 6, that's 30 degrees. That's going to be radical 3 over 2. And likewise, you can figure out the sine and so on. I'll just write those here. Sine of pi over 4, that's going to be equal to pi over 2. And sine of pi over 6, that's equal to, well, 30 degrees, that would be 1/2. So now if I want, this is where we're wrapping up here, the cosine of 5 pi over 12, I would say that's equal to, let's see, cosine changes the silly sign. So that's 2 cosines. So that's cosine pi over 4 times cosine of pi over 6 minus, because I changed the silly sign, instead of 3 pi over 12 plus 2 pi over 12. Now I need to change that to a minus sign. So cosine changed the silly sign, and this is now sine pi over 4, sine pi over 6 as a subtraction. Okay, and we just plug in those numbers that we remembered from the unit circle up above. So this would be radical 2 over 2 times, what was that thing? Oh yeah, radical 3 over 2 minus radical 2 over 2 times sine of pi over 6, and that's going to be 1/2. Now don't leave it like this. That just looks cruddy. So change this around a little bit. We get radical 6 minus radical 2 all over 4. Okay, that's your answer.